we will be talking about other angles in circles, specifically interior angles. So a recap of previous videos, I talked about the central angle, which is where your vertex is in the center of the circle. And the formula tells us that the measure of that angle is going to equal the measure of its intercepted arc. So the arc that is subtended to that angle is going to be exactly the same measure. If we are talking about the inscribed angle, then that's where you have your vertex on the edge of the circle. And it also has a formula of its own, which says that that measure of the angle is 1/2 of its intercepted arc. So make sure that you understand that they are two different angles and their vertex tells you which is which. What we're talking about in this video is the case where you have angles, because there's more than one, that are created from two chords intersecting inside of a circle. So for my vertex of this specific these angles, they are neither in the center nor on the edge of the circle. So they have their own formula, which states that the measure of the angle is equal to 1/2 of the big arc plus the small arc. Because there's more than one angle, I have to know what I'm working with. So for angle E, I have 4 different angles that can go with that. If I'm looking for angle GEA, because I can't just say angle E, because again, I don't know which one I'm talking about, I see that I have a vertex angle, a vertical angle, which is the angle that's directly across from it, that is going to be congruent to it. So I could write that if I wanted to as, let's see here, angle GEA is going to be congruent to angle RET if I were trying to write a congruent statement, but that's not what my focus is right now. So what I'm going to do, and I should have just did this in the beginning, is show you that the vertical angles are across from each other on both sides. So the other vertical angles are these two angles. And notice for the first one, I had one arc mark, which tells me those two angles are congruent. And then for the second pair of vertical angles, I have two arc marks. Pay attention to the symbols in geometry, they matter. And now what I want to do is I want to pay attention also to which arc goes with which and which angle and which arcs go together. So let's do this again. If I'm working with these two angles, the arcs that go with them are the ones that are subtended to the angle. So there's an angle there, and that's the arc that goes with it. And there's an angle here, and the arc AT is what goes with it. So those are the only figures you would be worried about. And then the same thing on the other side if I were working with the other one. So let's just dig into the examples that we have here. Go ahead and dive into those. I'm still using this formula. The measure of the angle is equal to 1/2 of the big arc plus the small arc because I have interior angles. So I'm looking at what's given and I see an angle here, which I know is going to be attached to the vertical angle, and that's the arc, and that's the arc. So that's what I'm working with. So what I want to do is just fill in what I know. What I know is that the measure of the angle is 13x minus 7, and it's set equal to 1/2, which is part of the formula. The big arc, well, 155 is bigger than 65. When it's adding, it doesn't really matter, but you just want to be consistent. And again, the arcs are the ones that make up the edge of the circle. So make sure you understand the difference between an arc and an angle. An angle has a vertex with two sides connected to the arc so that you'll know what to substitute in. So now you just want to simplify. I have 13x minus 7 is equal to 1/2. And since those are like terms, I can combine them, and that's 220. Because I have a fraction, I want to multiply both sides times 2. Over on the left-hand side, be careful because you have to distribute that 2 to everything that's in the parentheses. And the purpose of doing that was to get rid of this fraction. So now once I simplify, 13x times 2 is 26x, and then 2 times -7 is -14. Now I can bring down to 220. I'm going to add 14 on both sides, and that will result in 234. Divide both sides by 26. X is 9. Okay, so part B asked me to find the measure of angle ECD. So again, I'm looking at the symbol and I'm following the directions that are shown here in that order, E, C, D. So I'm trying to find this angle. And what I know is it's shown as an expression. So it's shown as 13x minus 7. Well, the x we just determined is 9. So that's what we're going to put in for x, minus 7. And once you simplify, the measure of angle ECD is 13 times 9 minus 7, which is 110 degrees. So angles and arcs are always measured in degrees, so don't forget to put that symbol there. And then you want to go on to part C, which is asking for the measure of angle LCD. And what I know, now this part can be tricky for some, is that there's a straight line here. And the part that I'm trying to find right now is this angle LCD. Well, there's nothing there. So I have to go back into my memory for something that I learned before about a straight line. I know that a straight line should equal 180 degrees, and I have just created a linear pair. So that linear pair, if I add it together, is going to equal 180 degrees. So I know that angle ECD is 110 degrees because I just solved for it over here. And so what I have to do is just add it to angle LCD, which we don't know yet. And because it's a straight line or a straight line created by a linear pair, I know it has to equal 180 degrees. So now when I'm solving for X, I subtract 110 on both sides, which leaves me with 70. But I'm looking for the measure of angle LCD, so I write it as 70 degrees. That's my final answer. In example 2, I'm still using the same formula because again, I still have interior angles and I'm solving for X. So I'm looking for what's given. I have an arc that has an arc measure of 63. It's attached to an angle. And this angle is its vertical angle, which is attached to another arc. So I know I'm working with that section. And now I just substitute what I know. What I know is that the measure of the angle is written as an expression, 9x plus 3, set equal to 1/2 of big arc. I don't know because this is shown as an expression. So I personally just like to put my variable first, but it doesn't matter. Plus, because that's the formula, the small arc, which is the other arc that's given, 63. Because I have information on the left-hand side, I want to go ahead and multiply both sides by 2 so that I can get rid of this fraction. And on this side, since it is an expression, that 2 has to be multiplied to everything that's inside of the parentheses. And so I'm left with 2 times 9x, which is 18x, 2 times 3, which is 6. And then I bring down what's inside of my parentheses. Actually, I can just go ahead and simplify that. Negative 3 plus 63 is going to be positive 60. And then if I keep, I'm sorry, I don't know why I'm out of breath. Okay, if I keep simplifying, I am going to subtract 9x on both sides. And then all in the same step, I'm going to subtract 6 on both sides. If I am doing my work correctly, on the left-hand side, the constants go away. On the right-hand side, the variables go away. And simplified, I have 18x minus 9, which is 9x. Set equal to 60 minus 6, which is 54. Divide both sides by 9, x is equal to 6. All right, from this point, I've satisfied that requirement. I want to go on and I want to solve for, or solve, find, or use interchangeably, the measure of angle SVR. So again, following my directions, SVR, I'm trying to look for this angle. Well, I don't see anything there. Well, yes, actually I do, because this is a vertical angle, which means that it's set equal to the angle that's across from it. So the angle across from it is shown as 9x plus 3. We just found what the x equals, so we'll just substitute in for x as 6. And so therefore, the measure of angle SVR is 54 plus 3, which is 57 degrees. And now we will go on to the next one, which is, this time pay attention to the symbol, which I somehow erased. So let me put that back there. Sorry, that should be an arc there. Let's see if we can fix that arc. Sorry, you guys, me and my, oh my gosh. Okay, that's an arc. There, that's better. So what I want to do here is to find the measure of arc RS. I look at what's given in my problem there. Move that out the way. And it's shown as an expression as well, 9x minus 3, but I'm going to replace that x with the 6 that is shown above. And so therefore, the measure of arc RS is equal to 54 minus 3, which is 51 degrees. So technically I am finished with everything, but if I wanted to check my work, I would just substitute in to my original problem. So my measure of the angle, I will put in the 57, set it equal to 1/2. Well, my big arc is 63 and my small arc, we just said was 51, and you will see that it will balance. If this was helpful, make sure that you like and subscribe for the video. Thank you, or to my channel. Thank you.